Alright, so the last thing we're going to do with this lesson, now that we spent some time using all the concepts we learned in this unit to prove or classify different types of shapes, we're going to use these concepts to try and prove some geometric properties. So the nice thing about the types of questions, and you'll see as you go through them, is that you're trying to prove something. What you're being told to prove is sort of laid out for you in the question. For example, if you see part A, it says show that these points lie on a circle with this equation. Well, it tells you what to do. You just have to show it. For B, it says show the perpendicular bisector passed through the center of the circle. Again, it's telling you what kind of math to do. You just have to go through the math and actually show the work. So that's a nice thing about this, but let's go through this together. So 1a again, it says show that the points A at negative 4, 7 and B at 1, 8 lie in a circle with the equation x squared plus y squared equals 65. Now this is a very, very easy thing to show using Desmos. Now that's not going to be sufficient on a test or quiz. I'll show you how to algebraically prove it, but just to get an idea of what's going on, here's a picture. So here's a circle, x squared plus y squared equals 65, and I've put the 2 points A and B on there. So this would be A out here at negative 4, 7, and B is over here at 1, 8. You can see very clearly that these points are on the circle. Okay? And part B asks us to show that the perpendicular bisector of AB passed through the center of the circle. So before we get to B, let's talk about A. So if a point is on a certain equation, line, circle, whatever, all you have to show is that the point satisfies the equation, i.e. when you put the point into the equation for x and y, it makes the equation true. So that means for point A, if I put negative 4 in for x and 7 in for y, I should get the left side equaling the right side, and ditto for the point 1, 8. So see what that looks like here. So if you want to show the A and B lie in the circle, you use a left side right side chart, much like what you used in grade 9 to try and prove your solutions to an equation was correct. So we take the point negative 4, 7. The left side of the equation is x squared plus y squared. The right side of the equation is 65. So I put in negative 4 for x and y and 7 for y. I wind up negative 4 squared plus 7 squared is 65, so that point is on the circle. For B, 1, 8, you do the exact same thing. Put 1, 8 in for x, 8 in for y. 1 squared plus 8 squared is 65. It's the same thing that's on the right side. So again, these points are on the circle. If the points were not on the circle, you'd wind up with a different answer for left side and right side. Okay, so that answers part A. Now, part B is a little bit trickier. So it says it wants us to show the perpendicular bisector of AB passed through the center of the circle. So if you have a perpendicular bisector of AB, so if we're going to try and construct that, just to see what it kind of looks like here, if we take the line and we go between A and B right here, we're looking for the right bisector of this. So remember, a perpendicular bisector is a line perpendicular to this line segment I just drew, but passing through the midpoint. So again, I'm just going to do a quick little sketch here. So the right bisector, if I approximate the midpoint being right here and it goes perpendicular, I should get something that looks something like this. Okay, so again, this is just a rough drawing here, just to sort of show what I'm trying to see here. If it's a right bisector crosses through here at a 90-degree angle, and I want to show that this line passes through the center of the circle, which, as you know from looking at the equation, is going to be at 0, 0. Okay, now again, visually I can sort of see how this might work, but I have to be able to prove it. So what I'm going to do to show this is actually find the right bisector first. So if you don't remember how to find a right bisector, go back to the first lesson in this unit when we first looked at midpoints and medians and right bisectors. You can see an example there. But what we need to do, remember, to find the equation of a line, we need two things. We need the slope, and we need a point. Okay, now the point we can use to find the right bisector here, the only point we know it's going to pass through is the midpoint of AB. Okay, so I'm going to calculate that up here. So my midpoint of AB is going to be halfway between the x and y values for A and B. So negative 4 plus 1 is negative 3 divided by 2 is negative 3 over 2. Okay, and for y, 7 plus 8 is 15 divided by 2 is 15 over 2. So that's a point that I know is on my right bisector. That's going to be this point right here. Now, for my slope, excuse me, I'm just going to write my point here, negative 3 over 2, 15 over 2. Now, I don't have enough information on this right bisector here to find a slope because I need 2 points. But what I do know is that since it's perpendicular to AB, if I can find the slope of AB, my right bisector will have a negative reciprocal for its slope. So the slope of AB, again, using the same 2 points I have here, I go y2 minus y1, 8 minus 7. x2 minus x1 is 1 minus negative 4. that's going to give me for a slope 1 over 5, which means the slope for my right bisector is going to be the negative reciprocal of that, which is negative 5. So now I have my slope, I have my point, I should be able to make the equation of a line. If I use point slope form, that'll be y equals negative 5 x plus 3 over 2 plus 15 over 2. Okay, so now I have the equation of a line. So at least I found the perpendicular bisector of AB. Now I gotta show that it passes through the center of the circle, which is 0, 0. If I want to show it passes through the center, I just need to show that this point, the center, is actually on this line. So again, if I do a left side, right side check by subbing in the point 0, 0, I should get left side equaling right side. So I'm going to do that over here. So the left side of my equation is nice and easy, it's just y. The right side is a little bit more complicated, negative 5 x plus 3 over 2 plus 15 over 2. Okay, and I'm going to put in 0, 0 for x and y. So my left side is just 0 now, because y is 0. For my right side, I get negative 5 times 0 plus 3 over 2 plus 15 over 2. So when I simplify that, 0 plus 3 over 2 is, of course, 3 over 2. 3 over 2 times negative 5 is negative 15 over 2. So I get negative 15 over 2 plus 15 over 2, which, lo and behold, is 0. So my left side equals my right side. So when I put the center into my right bisector, it satisfied the equation, which means the center is on the right bisector. Okay, so as it actually turns out, the perpendicular bisector of any chord on a circle passes through the center. So what that means is you can take any circle you want. So I'm just going to draw one in here. Okay, you can take any 2 points that are on that circle, which will make a chord. Let's say I take, let's just draw a chord in here. Let's say I connect this point with this point right here and create a chord. The right bisector of that should pass somewhere through the center of the circle. So again, I'm just going to draw it roughly. If my right bisector looks something like this, it means somewhere along here the center of the circle should exist. Now it looks like on my picture that that's the case, but again, now that you know this is true, you should be able to prove it for any circle and any 2 points on a circle I give you. Okay, the other thing to note here, when you think about circles, is that the center of a circle is just a circumcenter of a triangle whose 3 vertices are on the circle. So let's say I have 2 points that are on this circle here. I'll take the 2 points I've already drawn, this one and this one. Let's say I add another point on here, somewhere on the circle. Let's say it's, let's say here. And I make a triangle from those 3 points. Okay, because these 3 points are on the circle, these 3 points are all going to be the exact same distance from the radius. The same distance from the center. That distance will be the radius. So that distance, and that distance are the same. So if that's the case, I mean, you have a point that's the same distance from all 3 vertices of the triangle. We looked at that a few lessons ago. That is defined as a circumcenter. Okay, so, and since circumcenter is the intersection of all the right bisectors, that's where that whole idea comes from as well. The right bisector of each of these chords will pass through the center, and where all the right bisectors intersect at the center is going to be the circumcenter as well. So that's a neat little theorem as well. That's just a little byproduct of all the stuff we've been doing so far this unit. Okay, so that's our first proof done. Now let's take a look at another one. So I'm going to give you a triangle, has vertices at negative 2, 2, 1, 3, and 4, negative 1. I'm just going to sketch those. So negative 2, 2, 1, 3, and 4, negative 1. Okay, and I want you to show, so again, it tells you what it wants you to show. The mid-segment joining the midpoints of RQ and RP is parallel to PQ and half its length. Now it seems like a mouthful to say, but let's just try and go through it slowly so we can figure out what it's saying. So you want to show the mid-segment, and it says this mid-segment joins the midpoints of RQ and RP. So somewhere along RQ you're going to have a midpoint. So I'm just going to estimate it for now and put it right here. We'll calculate it later. Somewhere around RP you're going to have a midpoint. Again, I'm just going to estimate it for now. I'm just going to say it's around here. So this mid-segment right here, this line connecting these 2 points, it wants you to show that it's parallel to PQ, so parallel to this line right here, and half as long. Okay, seems simple enough, but we got to be able to find its length and its slope to compare it. So what I'm going to do first is I'm first going to find the two endpoints here of this line segment I just drew. So I'm going to find this midpoint, which I'll call A, and this midpoint here, which I'll call B. So A is going to be the midpoint of RQ. So halfway between R and Q, so I'll go 1 plus 4 divided by 2, and then 3 plus negative 1 divided by 2. So that's going to give me the midpoint there. So that point A is being 5 over 2. And 3 plus negative 1 is 2 over 2 is 1. Okay, so I'll do the exact same thing for my other midpoint. Let's just find B. So it's going to be halfway between P and R. So negative 2 plus 4 is 2 divided by 2 is 1. And 2 plus negative 1 is 1 divided by 2 is a half. So right there I have now these two coordinates right here. This is going to be at 5 over 2, 1. And this is going to be at 1 and 1 over 2. So now it wants me to show that this line segment connecting these two midpoints right here, it's parallel to PQ and half its length. So let's just deal with the parallel part first. If they're parallel, you know their slopes are going to be the same. Okay, so let's calculate the slopes of both this line segment right here, the AB, and the slopes of PQ. Actually, I'm going to have you do that on your own. So calculate the slopes of each of them and see how they compare to each other. Hopefully they're the same. I mean, they're telling you they have to be the same because it has to be parallel. So go through it, make sure your math works out, and push play and ready to go through it together. Okay, so just to show you calculations here, for my slope of AB, it was a half minus 1, so y2 minus y1 over 1 minus 5 halves. That gave me negative a half over negative 3 halves, which simplifies to 1/3. When I did the slope of PQ, it was 3 minus 2 over 1 minus negative 2, which again gives me a slope of 1 over 3. So because these two slopes are the same, I've now proven that this mid-segment here going from A to B and this line PQ are going to be parallel to each other. Okay, to show that, so I've proven the first part. Now I have to show that it's also half the length, that AB is half as long as PQ. Well, how do I compare lengths? That involves looking at distance formula. So I'm going to need to calculate here is the length or distance from A to B. Okay, and again the length or distance from P to Q. So again, I'm going to have you do that on your own, use the distance formula, and see if you can get it to work out where the length of one is half the length of the other. Okay, push the player to go through it together. Okay, so you can check your math here. So I calculated the length of AB using the distance formula. Had some fractions simplify. Once I got through that, I got the square root of 5 halves, which is approximately 1.58 units. I did the same thing for the length of PQ. When I simplified that, that was a little bit easier. I got the, oops, I forgot a bracket here. I got the square root of 10, which is about 3.16 units. If you compare these two values to each other, the 1.58 and the 3.16, this one, the length of PQ is double length of AB, which is exactly what I was trying to show up here. I wanted to show that the mid-segment was half the length of PQ, which is exactly what I showed here. So again, now that I've calculated the distance, I can prove it, and I'm finished. Okay, so some of these can seem a little bit tedious, but again, the nice thing about it is it's telling you what it wants you to prove. You just have to go through the math and prove it. So one last example. So I'm giving you a rectangle with these 4 coordinates. I want you to prove the diagonals of the rectangle are equal and that they bisect each other. So what does it mean for them to be for the diagonals to exist? So just looking at a rectangle right here, I know this is not a Cartesian plane. Let's say this is A, B, C, and D. The diagonals would be the lines connecting the vertices that are across from each other. So this would be a diagonal here going from A to C. This would be another one here going from B to D. So once you prove that these two lines right here are equal in length and that they bisect each other, bisect meaning they cut each other in half. So I'd like you to try doing that one on your own first, and I'll run through it together in part 2.